Hello guys, in this video I wanted to show how our weight or the weight of the object is changed when the object is moving upward in the lift or when it's moving downward. Okay, what do you expect? Okay, what do you expect when the body is moving in the lift upward? Is the weight of the body increase or decrease or the same? And what about when the body is moving downward in the lift? Does its weight increase or decrease? Okay, this will be given by this video. Please attend me, and if you get this video is important to be one of the member of my viewers, let you subscribe for this video. Okay, here is a typical example that shows when the body is moving upward or downward. Okay, for example, here the acceleration is upward. The acceleration is upward. Okay, here the acceleration is upward. Here the acceleration is downward. The question is there any difference between the readings of this spring balance meter and this one? Okay, this analog spring balance and this one, the two, which one read larger? Which one read larger, this one or this? Okay, think for a while why the reading is the same, different, or why the readings are the same. Okay, to answer this question, it's not difficult if you understand well. You know, for example, if you wanted to measure the mass of the spring at stationary on the earth surface, okay, you can use this spring balance or spring scale reading, and you can record it. And when you are moving uplift in your lift, okay, upstairs, you can read the weight of this fish within the lift. Is there any difference between your reading, you are on the floor and you are in the lift which is moving up? Is it less than or greater than? For example, if the weight of the fish is 5 kilograms on the floor, what will be the reading of the spring balance here when the fish is moving up and when it's moving down? Okay, for this effect you can practically done if it is accelerating lift. For example, if the acceleration of the lift is the same, that is constant, that is acceleration is 0, okay, moving up and moving down may not have different value, because tension minus mg will give us mass times acceleration. So the acceleration is 0, tension is equal to mg. Here the tension means the reading of the spring balance. In the same fashion, when it's moving down, mg minus t, mass times acceleration. If mass times acceleration is constant, acceleration is 0, so mg and tension is equal. So moving up and moving down in the lift with a constant speed is the same as the reading on the floor. Okay, if the motion of the body is not uniform or constant velocity, that means it has its own acceleration. Moving up and moving down will have different effect. Okay, that means T minus mg is equals to mass times acceleration. Okay, it has mass times acceleration, so that that's T times, if it's moving up, the tension is greater than what? If it's moving up, you know, tension is greater than mg. That is, acceleration is what? The value of acceleration is different from zero. Different from zero. Greater than zero, or okay, it's greater than zero in magnitude. In absolute value, I can make it absolute value. In absolute value, okay, the magnitude of A is greater than zero. Okay, if A is greater than zero, or mg is what? Mg is greater than tension. Mg is greater than tension. T what? If A is less than zero. A is less than zero. Okay, so what will happen for upward motion? This is for downward, this is to say downward, moving upward. Okay, moving upward. So for moving upward, let me give you space. Okay, yeah, for moving upward, what do you expect? Tension is greater than, so the motion is upward. Tension minus mg will give us mass times acceleration. Okay, you can say this is 1. Okay, here tension will be what? Mg m times acceleration plus mg. Okay, this is 2. So tension can be written as mass times acceleration plus g. Okay, For moving downward, for example, we can do example acceleration, moving acceleration, upward acceleration is positive, upward, okay, you can say that, for example, acceleration, upward acceleration A equal to 2 meter per second, and M is equals to 5 kilogram. So tension will be 5 kilogram, 5 times into, or 5 kilogram, can I write 2 times 2 plus the acceleration is assumed 10, assume 10 meter per second, so this will give us tension is equals to 5 times 12 kilogram meter per meter per second. Okay, this tension SO is equals to this force 5 times this 10, 160 Newton. Okay, Newton, which is equivalent to the mass is assumed to be 6 kilogram. Okay, so we assume that tension is equals to mass times assume G tension, let us the new mass apostrophe new mass, so the new mass and apostrophe is equals to 60 Newton divided by 10. Okay, M will be 6 kilogram. In the same fashion, okay, if it's moving downward, okay, tension at mg minus tension is equals to mass times acceleration. So here tension this one, so tension is equals to mg minus mass times acceleration. This is 2, again tension is equals to mass times 2g minus acceleration. So if you do the example, or this example 1, say, okay, from example 1, from example 1. Example 1, tension is equals to 5 kilogram times G 10 minus acceleration 2 meter per second. So this tension is equals to 5 kilogram 10 minus to 8 meter per second. So tension is equals to 5 times 8, 40 kilogram meter per second. So tension equal to M prime G. So M prime is equals to tension divided by G. So M prime is equals to it's 40. Here is 40 Newton. Okay, this is equivalent to 40 Newton. So here, okay, 40 Newton divided by 10 G, 10 meter per second. So M prime is equals to 4 kilogram. So this is instead of M, because double apostrophes. Okay, assume like double story. Okay. So here we can see that here okay, now here we can see that M prime is greater than M double prime. So this is an illustration. Okay, this is an illustration to see the difference between the mass due to motion of the body moving within the lift upward or downward. Its mass effect due to the motion will be changed. This is apparent mass. Okay, so we can have different mass. We can have mass as 5 kilogram, mass as 6 kilogram, mass as 4 kilogram. Depends on the acceleration of the body moving, whether it is upward or downward, or when it is at rest on the surface of the floor. Okay, so it is very interesting effect. Okay, it's a very interesting effect. I think you can study in detail to understand also the relative motion of the body. I think it is enough for today. Don't forget to subscribe. Okay, to and also my next videos. See you, bye bye.